Hello, discrete math fans. So we all have a sense of what a function is. It's a rule. It maps elements of one set to another. Once we have an input, there can only be one output. Now early on, we defined a function as a type of relation. Let's give a formal definition of a function. So a function from a set x to a set y, which we'll write f with a colon and then x and then an arrow and then y. First and foremost, it's a relation. It's a relation from x, which is the domain, to y, which is the codomain, and it has to satisfy two properties. Every element in x has to be related to some element in y, and, very important, no element in x is related to more than one element in y. Another way of saying this, and another way of writing this using the notation that we have for relations, given any x, little x, in the set x, there's exactly one element, little y, in big Y, such that x comma y is an element of f. And so what we're going to do is we're going to say that f sends x to y, or maybe we'll say f maps x to y. And then there's a lot of different ways we can write this. We can write x with an arrow to y with an f above it. Or we can say that f takes x to y, using this notation. Or we have the more traditional notation, f of x equals y. That's the one that we're all used to. Here's a new word that we'll use. We're going to say that f of x is called the image of x under f. And then the set of all values of f taken together is called the range of f, or the image of f. So in symbols, we'll say that the range of f is the set of all little y in the codomain, such that y is equal to f of x for some x in the set x. Now, given something in y, there might be some elements in big X with y as their image. So if f of x is equal to y, then we're going to call x a preimage of y, or an inverse image of y. So we're going backwards now. The set of all preimages of y is called the inverse image of y. So in symbols, this preimage of y, it's a set. It's a set of all things in the domain such that f of x is equal to y. Now I would suggest that depending on what math books or papers you read, the notation f of x is sometimes abused to refer to both the value of the function at x and the function f itself. We're going to try very hard to avoid this problem. So if we do it properly, the notation f of x will refer to the value of the function of f at x, and not to the actual function itself. Now I've talked about arrow diagrams for illustrating functions defined on finite sets. All right, so here's an example of an arrow diagram. Now this particular arrow diagram, it defines a function because, first, every element of A has an arrow coming out of it, and second, no element of A has two arrows coming out of it that point to two different elements of B. So let's answer a few questions about this particular function, f mapping from A to B. So what's the domain and codomain of the function? What's f of A and f of B? What's the range of f? Is C an inverse image of 1? Is there an inverse image of 3? Find the inverse image of 1, 3, and 4, and finally we'll write f as a set of ordered pairs. That may be helpful if you can look at the arrow diagram while we're talking about this. You might consider just jotting down the arrow diagram for reference as we go through this. All right, so the domain is the set of all things that we are mapping from, so that's the set containing A, B, C, D. The codomain is the set where we could get our outputs, so that's the set 1, 2, 3, 4, 5, 6. There doesn't need to be an arrow going to some element in order for it to be in the codomain. There's no arrow going to 2, 3, and 6. That's okay. It's in the codomain because we're just setting that up to be possible locations or possible outputs of the function. All right, so the codomain is the set of elements where we could map to. F of A is 4, F of B is 5. The range of F is the set of all destinations for our arrows, so that's 1, 4, and 5. We're going to make a distinction between the range and the codomain. The range is a subset of the codomain. It consists of the set of all elements in the codomain that has an arrow going to it. We're going to say that C is n inverse image of 1. The language here is very important. It's an inverse image of 1. There are actually more than one inverse images of 1. We can also say that D is an inverse image of 1. There is no inverse image of 3 because 3 is not in the range of the function. There are no arrows that point to 3. So now if I want to talk about the inverse image of 1, what we're talking about is the set of all things to get mapped to 1. And so that's the set containing C and D. Meanwhile, the inverse image of 3 is the empty set because nothing gets mapped to 3. The inverse image of 4 is the set containing A. And finally, we could write this function as a set of ordered pairs. And if we do that, then we'll say that F is equal to the set containing the ordered pairs A, 4, B, 5, C, 1, and D, 1. And of course, this only works if we're thinking about a function on a finite set. Okay, that's all for now.